Okay, let's quickly go over this practice quiz. So make sure you understand everything that's on this practice quiz and make sure you also look over the big idea assignments together. That's going to help you do well on this quiz. So, this first problem, we are told to find the fifth root. So, I'm going to write it this way of negative 243. So, this is just asking you, hey, can you use a calculator? So there's two ways that we can do this problem. We could do the 5, that's the fifth root, hit the math key, and option 5 is the fifth root of negative 243, and it's going to tell us negative 3. And that's your only answer. Do not put plus or minus here. Only a negative 3 is the answer. So another way that you could do this problem, we could type in our base to negative 243. Notice I'm putting in parentheses. That's going to be very important, especially if it's an even root. So I have our base in parentheses, and I can raise it to the 1/5 power. I'm going to still get negative 3. So just make sure that you understand at least one method to be able to take roots. Okay. So then this one is the sixth root of 64. It's going to be your job to know that an even root has two answers. So this is going to be a plus minus. So I can, again, just to show everybody on our calculator, I can do the sixth root. So I'm going to type in my 6, hit the math key, and option 5. Now, some calculators, you can hit option 5 right away. But if you see an answer here, then type in the root first. So some of the calculators are not quite updated depending on what calculator you have. But for this calculator, I have my sixth root of 64. You're going to see that it tells you 2, but it's going to be your job to realize negative 2 times 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 negative 2 is also 64. So two answers. And again, I could have also raised 64 to the 1/6 power to get that too. Okay. So here, this is just, again, calculator work. So this section on your test, you can just simply type what you see. I see 10 being raised to the negative 3/4 power, and I have point 0.1, and we'll round to the nearest penny. So that 7 should become an 8. So 0.18. For this, you only just need the positive root. Okay, you don't need plus. Even though this was an even root, I don't need to see the plus or minus for this problem. So just how it's written on paper. This one, I could type in exactly what I see in my calculator. So I see parentheses, I see the fourth root, so math key, and then option 5. I have a 12. I push away, close the parentheses, raise it to the ninth power. And we're going to see that this answer is about 268.01. So about. Okay. Another way of getting that same answer, or we could take 12 raised to the 9/4. It's still the same answer. So either way, let's just prove it on a calculator. I can write this in exponential form as 9. So the power goes on top, the root on the bottom, and we get that exact same answer. Okay, so whatever you feel is the easiest way to type in, that's what you should use on your test or quiz. Okay, these problems, this is just recognizing that we're dealing with the same variable. We're in the power. So these are like terms, believe it or not. So I'm going to rewrite this one. So I'm going to keep this in exponential form. It's 6x raised to the 7/10. But this also is, here's my power. Doesn't matter that it's inside. It's a 7 on top, 10 on the bottom. Now I can see that these are like terms, definition of like terms, same variable, same exponent. We have the same exponent. This time we're taking 6, take away 1. You're left with 5 of these. So this is an answer, or you could write it as 5, and then it's the 10th root of x to the 7th. Okay. So either answer is correct. So if you want to keep it in exponential form or radical form, you're perfectly fine. For this one, 100 is a perfect square root. So when you take the square root of each of these factors, and again, this only works for factors. If these were terms, you couldn't do this. But the square root of 100 is a 10. And then what you have to remember is these variables are really being raised to the 1/2 power. Okay. So when you have a power raised to a power, you simply multiply. 12 times 1/2 is a 6. 2 times 1/2 is a 1. And there's your answer. Okay. So if you would take this times itself, you're back to what's underneath the radical. Okay. So works out nice and neatly. It's a pretty straightforward problem. This one is just describing the transformation. So here's my original function. It's just the fourth root of x. I see that we have a number greater than 1, so it's a vertical stretch. Okay, then the other movement, we have a -5, so that means it's to the right 5. Okay, and you could always double check on a calculator. You could plug that in to your calculator and see that you're actually moving to the right 5 if you get confused. Okay, so here is number 8. You're guaranteed to see this problem. You are going to multiply both top and bottom by the complex conjugate, which sounds fancy. All it is I take the denominator and change its sign. So I have 4 plus root 7. Whatever you do to the bottom, we're going to also do to the top. So we're going to clean up the numerator. 5 times 4 is just a 20. 5 times root 7 is simply 5 root 7. Okay, you can't get root 35. It doesn't work that way. It's just 5 times the square root of 7. On the bottom, we're going to end up with a nice number, okay? Because when I take 4 times 4, so there's a binomial times a binomial. 4 times 4 is 16. This and this wipes out. There goes the radical. We no longer have a radical. And then we are left with minus root 7. Root 7 is root 49, but that is simply minus 7. So 16 minus 7, we get a nice 9. And that is considered simplified. Like I said, it doesn't look any simpler than what we started with, but we no longer have a radical in the bottom. So that's the goal. So then the next page, we want to get these to be the same. Okay, so right now we're dealing with the cube root of 320, and we have 9 cube roots of 5. Chances are I'm going to be able to break up 320, where I'm looking really for the largest perfect cube that fits into 320, but I'm going to feel pretty confident that when I take my calculator, so here's my calculator, when I take 320 divided by 5, we're going to see a perfect cube. And it's 64. 64 is a perfect cube. And the cube root is 64. Just to prove this, if I raise this to the 1/3 power, I get a 4. So by breaking up 320 as 64 times 5, this really is 4 cube roots of 5 plus 9 cube roots of 5. Notice these are the same. That's the only way you can combine when they're terms, is if they are identical. Same base, same power. So now we have 13 of them. Okay. You could always check if you have time on your quiz. You could always type this in, get a decimal, and your final answer better be equivalent to that decimal. Okay. Number 10 may look very difficult, but it's super easy. We could do this without a calculator. When I see that we're dealing with all factors, again, this would be a totally different story if these were separated by plus or minus signs. But since they're all factors, I can take this 10 and it fits into 33 times. So I can cross this out and make this just a 3. Okay. Cube root of 30 over the cube root of 10 is just the cube root of 3. And then I'm allowed to take 3 times 9, since they're the same power. It's the cube root of 27, which happens to be a nice 3. Okay. And again, you can verify this on a calculator. If you're going to use a calculator, just make sure you realize this needs to be calculated first before you divide by the cube root of 10. But your calculator should tell you that the whole thing is 3. Okay. So now we come down to some review questions. So this is just keeping you honest. Never forget to factor. The ability to factor. Notice we're not solving anything. It's not equal. So it's just telling you to break this down into factors. So factor completely. So I'm going to do the diamond, okay, only because there's a 4 in front. So our job is to figure out what times what gets you back to the original problem. So I'm going to take A times C. It's a 24x squared. We're not going to give up until we can find a way to get an 11. Okay, so my brain's been working. I know 8 times 3. And I also know that adds up. So 6 and 4 you may have thought of, 2 and 12. You can't give up until you find 8x and a 3x. And so what we're going to do is just turn this into a grouping problem. I'm going to replace the 11x with an 8x and a 3x. Again, the order doesn't matter. So if I wrote the 3x first, that's fine. But when I split down the middle on this side, we have a 4x in common. So we're going to be left with an x plus 2 in parentheses. Over here, you can factor out a 3. That's what goes into both of these terms. And the good news is we know we did this correctly when we see these are identical. So x plus 2 is one of my factors. The pieces on the outside make up the other factor. So you can always check by multiplying this times this. Hey, we're back to this. Your outers and your inners, that's basically what you're finding. When you're doing a diamond problem, you're figuring out what your outers and inners have to be to add up to that middle term. And a 3 times 2 must agree with this. So we are finished. It's factored completely. Stop there. Do not tell me the answers. I'm not looking for -2 and -3/4 because it's not an equation. It's not equal to 0. So just stop at your factor. This one, we don't even need a diamond because we are factoring a quartic. So we're locked in at x squared. We're also locked into a plus and a minus because this is a -50. So this number times this number must be a -50, but then we do want to come up with a combination that adds up to a -23. So I know this has to be a -25, and this has to be a 2. You say, where does the -23 come from? The -25x squared and the +2x squared will add up to -23x squared. Now, if you stop here, you will see that I will take a point away from you on your quiz because technically we're not done factoring. I can't factor x squared plus 2. There's no way of breaking that up. But this happens to be a special case where I can break it up as a perfect square minus a perfect square. Square root of 25 is a 5. So I'm going to use a +5 and a -5. Now we have it fully factored. Okay, so just be aware of if you see a perfect square minus a perfect square, factor completely. Okay, now this one, you are going to graph and you are going to state the domain and range. Now, we shouldn't have to rely on a calculator for this, but you're allowed to use a calculator. Okay, so with this, I know that this is a reflection. So really, this is the same as negative square root of x plus 2. So when I graph this, I know I'm shifting everything up 2, and it's also going to be reflection. So the graph is actually going to go downward. Okay, but let's type this in the calculator. Do your negative. So underneath the 3, so right there was my negative. I click right there, the negative. And then I'm going to do square root of x. Now make sure you push away and put a +2. Or you could have typed in a 2 minus. So you could have typed in exactly how it's written on your paper. But the graph's going to look like this. Okay, that's somewhat helpful. When I go to my table, I'm going to be able to see really my domain. We're not going to be able to plug in any negative numbers. So x cannot be a negative number. So we can plug in a 0, but we can't plug in negative. So I might as well state the domain right away. So domain, we are going to restrict it to x values that are 0 and above. So the first point we're going to plot is 0, 2. Okay, I can see that on my table. When x is 0, y is a 2. When x is a 1, Square root of 1 is 1. 2 minus 1 is 1. So we're going to see that it's going to go down like this. So let's gather a couple more dots, like 4, 0. And then I don't know if we have, yeah, so, and then I don't quite give you enough room to do 9, but I'm going to fit it. If we had enough room to go here, 9 will be down at 1 or negative 1. So when I connect these, I see my graph looks like that. So then looking at this graph, looking at your table, you can see that the largest Y value, the peak for my outcomes was 2. So if this was money, the most you ever had was $2. All the other points will have Y values less than 2. So my range, Y values less than or equal to 2. Okay, I had to sneeze there. But we now have to write a rule. So this rule, this is obviously a cubic function. Okay, so if you look in our notes, we basically dealt with square roots, which will be some version of this, could be a reflection. This, though, is a cube root function, but we moved it. So right here, normally the cube root of x starts at the origin, but we moved it 1, 2, 3 places to the left. So left, 3, and then it looks like we went down 1, 2, 3, 4, 5, 6. Down 6. And it's our job to write a cubic function with those conditions. So no stretches, no reflections. All we have to do, I'll shift down here. So here's our rule. Cube root of something. So we'll do the easy part. The down 6 is just going to be a minus 6. Okay. But if we're shifting to the left 3, we must go inside where that x is and add a 3. And you say, why in the world will we add a 3? Well, now I can plug in a negative 3. So if I plugged in a negative 3 in for x, negative 3 plus 3 is 0. Cube root of 0 is 0. 0 minus 6 is negative 6. So I have the point negative 3, negative 6 as a critical point in my graph. And so I could also double check my rule. I could ask the calculator to graph, this is option 4, so the cube root of x plus 3, push away minus 6, it should look like what was on our paper. Okay, so on your quiz, expect similar movements. I'll either move it to the left so many, up so many, down so many, and you just have to write a rule that represents the movements. Okay, should be easy, but just think about it. So if you had a minus 3 here, that would be to the right 3. Would it match up? So this rule needs to match up with the graph that's provided. Okay, one last page, and I've been talking for 18 minutes so far. We'll be able to get this done hopefully within a half hour. Okay, so this again is a review. We already solved radical equations, equations with square roots. So for this problem, I want my radicals on opposite sides. So I'm going to keep the 2x plus 13 on the left, but I'm going to pick this up and add it so that it's on the right. And once I do that, the radicals can disappear because I'm allowed to square both sides. So if I square both sides, it negates the square root. And now I have an easy equation that if I subtract an x, I'm left with x on the left. If I subtract 13, I get 9 minus 13, which is negative 4. And that is your answer. If you would replace this x with a negative 4, you will get 0 then as your answer. Okay, so just keep that in mind. You would end up, again, I'll just show this. If you plugged in a negative 4 here, you have negative 8 plus 13, which is root 5. If you plug in a negative 4 here, you also get root 5. Root 5 minus root 5, that's where we get a 0. So the only answer is negative 4. Now, I already quizzed you on this, but I'm sure a lot of us forgot this. we are going to solve this by undoing square root. So to undo square root, we square both sides. So here's the critical part about this. These are terms. So we're squaring a binomial. We need to, maybe you need to make a box or off to the side. You need to realize that's what we're doing. We're doing FOIL. So I'm going to end up with an x squared. And then my outers and inners are each going to be a negative 3x. So together it's a negative 6x. And a negative 3 times a negative 3 is a positive 9. That's where most students are going to mess up. Now, I also mentioned earlier in the year square, double square. So when I see I'm squaring a binomial, I don't need to write it out like this. I can square the x squared. I multiply what's inside my parentheses, and then I double it. So a negative 3x doubled, that's where the negative 6x comes from. And then I square the negative 3. Negative 3 times negative 3 is a positive 9. So I don't care how you get that, but make sure you square your binomial correctly. This side, the radical just drops. So you are left with a quadratic equation, and hopefully you know how to solve a quadratic equation by now. You are going to get 0 on one side. So I'm going to keep my x squared positive, and I'm going to hopefully have an easy problem to factor. So x squared minus 12x, and that's going to be, what is that, a 35. Okay, so this one should be pretty easy to factor. Two sets of parentheses, x and x. I know it's going to be minus minus. You say, why is it minus minus? This is a positive, so my signs have to be the same, but the middle term is negative. So ways of getting 35, not many ways. The good news is a 7 and 5 is all we need, because negative 7 times negative 5 is the 35 we need, but then the outers and inners would agree with the negative 12x. So here are your answers. Positive 7 and a positive 5. So if I just check, say, the 5, I plug in a 5 here. 5 minus 3 is a 2, so I'm left with a 2 on this side. When you plug in a 5 here, it's a 30 minus 26, which is the square root of 4. 2 equals 2. It makes the equation balanced. Same way with a 7. 7 would work as well. If you plugged in a 7, you would get both sides to equal a 4. Okay, so just keep that in mind. Here is a review of the quadratic formula. It is set up to pick out your A, B, and C. It's already in standard form. Now, some of you are still making this mistake when B is a negative number. So when we substitute these values into a quadratic formula, it's, here, let me write the quadratic formula. Opposite of B, that's still on my sideboard. So the quadratic formula, I'm hoping you have memorized by now. It's the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So when I see that my B is a negative, I'm going to have a positive on the outside. And then inside, you better put negative 8 in parentheses. Some of you still refuse to do that. So I don't know what else this tell you. If you're going to type that in a calculator without parentheses, it's going to give you the wrong answer. So parentheses matter around a negative when you're squaring. So 2 times 5. Okay, so we'll just clean this up. I'm going to pick up my calculator and calculate the discriminant. So I don't want to hit square root. So all I want to do is make sure the calculator can calculate negative 8 in parentheses squared minus 4 times 5 times 2. And it comes out to a 24. Now, I want you to realize this can be simplified. So this is a good answer. I'm pleased with this answer, but there's actually a better, more simplistic answer that I want you to be aware of. So we're dealing with square root. So square root of 24, here we're thinking about perfect squares that fit into 24, 4 times 6. So I'm going to break up 26, breaking it up any other way. 8 times 3, neither one's a perfect square. 2 times 12, that doesn't help you. You want a perfect square that's a factor. So 4 is the largest that fits in. So we really get down to this. And then the last thing we can do is we can reduce everything. Okay, notice all these numbers are even, so I can basically divide each of the terms by 2. Okay, so I'm going to make this 8 a 4. This 2 becomes a 1, and this 10 becomes a 5. Okay, you're allowed to do that. That just simplifies this. This is a correct answer. If you type this in a calculator, you'll get the same answer as if you type this into the calculator. So this is just in simplest form. So I just want you to be aware of equivalent answers, especially if you take the SATs. You need to recognize that this is the simplified answer to this. Okay, so just keep that in mind. Another way you can think of this, if I put a 10 underneath each of these, 8 over 10 is 4 over 5. 2 over 10 is 1 out of 5. So we have our common denominator 5 then. So that's another way of thinking about it. Okay, this one's super easy. We're dealing with a cube with a volume of 512. All you have to do is take the cube root. So all we're going to end up doing to find the dimensions of that cube. So here's my cube. So a cube has all sides being the same. So I'm just going to ask the calculator, what is the cube root? So I'll set this up as an equation. We're going to take our calculator, type in the volume, and easiest way, instead of taking the cube root, I rather raise it to the 1/3 power. Okay, and we're going to see that, hey, it's an 8. So in this case, it's 8 inches. Okay, you're done. These are all done. You're going to see a volume of a sphere on your quiz, guaranteed. And all I'm concerned with is that you do the work on a calculator. So you're going to take whatever, the only thing I can change is this number. Okay, this could be some other number I randomly pick, and you will undo this formula so that you will get it so that we solve for R. So here are the steps. Whatever the volume is, type into your calculator. So in this case, 1,258. I'm going to undo the 4/3. So this 4/3, it's being multiplied, so I can legally undo it by dividing. It tells me that answer. I don't need to write that answer anywhere. I'm just going to keep it stored in my calculator. And the next thing I'm going to divide by is pi. So try to use the pi key. Since we have a pi key on our calculator, you might as well use it. So right above the caret key right here, can you see my finger right there? I hit second, and then the caret key, a little pi symbol appears on my calculator. I'm going to hit enter, and it's this number I don't want to round. I just want to keep that stored in my calculator, and that is really what r cubed equals. So the last thing I need to do is figure out what r is going to equal. So instead of taking the cube root, that's how you undo cubing something, is the cube root. I can take this answer and simply raise it to the 1/3 power. Okay, and I'm going to see that this technically would round. So if this is rounded to the nearest penny, I would want you to put 6.70. Okay, so if this was money, you would get $6.70 back. And so in this case, we're dealing with inches. That would be the radius of that sphere. Okay, and the last problem, and I'm at the 28-minute mark, so I have 1 minute to try to get this problem done. So I end at the 30-minute mark. We are going to see if we were speeding. So we have this simplistic formula where our speed is equal to 4 times the square root of the distance of a slide. So we have a skid mark. So we hit the ground and then we slid for 250 feet. This should be able to tell us the speed. Okay, so all you have to realize is for this problem, the 250 is the distance. So D is the length in feet of a skid mark found on the road. You hit the brakes and you slide, and they measure that, and that can calculate your speed. So let's see if we are going faster than 45. So if we take our calculator, simple calculation problem, And if this answer is more than 45, this person was speeding. And you can see this person was going way too fast. It's only supposed to be 45 miles per hour. According to this formula, this person was going, let's round that up to a 5 miles per hour. So, was the car speeding? Yes. Going way too fast in a 45 mile per hour zone. They're going over 63 miles per hour. So that's a little application problem. Just read the problem, know where you will replace your variable, and then let the calculator do the calculation. So that is your quiz. If you understand those questions, you should do very well on your 5-1 to 5-3 quiz. Uh-oh, I went 45 seconds over. I apologize for that, but please make sure you understand all these questions and your big idea assignment questions. Look over the notes. I have the complete set of notes. There's extra problems to practice, some volume problems. When you look over the answers in the complete notes that you can look at to get yourself prepared for this quiz. So thank you for watching.